Are you here?
Yes.
Okay. Okay. So, gentlemen, Tahoe system, as I told, this engine is camshaftless. So, is required to one of the equipment, one of the machinery to check the position of the crankshaft to be transferred to the engine control system in such a way to have a precise timing for the fuel injection and exhaust valve activation. This equipment is Tahoe system. We have two Tahoe system for the same reason, to increase the redundancy of the engine. They are designed two Tahoe system A and Tahoe system B. The engine can operate just with one Tahoe system in normal condition, but if both of the Tahoe system are out of order, the engine cannot operate, as we don't the engine control system ECUs, so the governor and the CCUs, it will not receive information when to inject the fuel and how much to calculate the fuel, as doesn't know the speed. He are not available to check the speed of the engine. So without both of the encoder, the engine is inoperable. The Tahoe system each Tahoe system is consist an encoder and an amplifier box, which is realize the connection between the encoder and the one of the network. So encoder A, it's connect with the network A. Encoder B is connect by the network B. The encoder A, its power supply by ECU A, engine control unit A. Encoder B, its power supply by ECU B. The position of the crankshaft read by the encoder is transferred to all controller involved in the combustion process. So the data from the encoder is transferred to ECUs, and CCUs is transferred for ECUs to calculate the timing of the fuel injection and the fuel index, and is transferred to CCU in such a way with the data package received from ECU, the timing and the fuel index, to be activate the mechanical components, fuel injection exhaust valve in precise time according to the position of the crankshaft. So the data from the encoder is not transferred to auxiliary control unit, scavenge control unit, interface, or cooling water control unit. So just to the controller involved in the combustion process. Gentlemen, as I told you, the encoder A is located near the engine, encoder B is located outer the engine. Each encoder has two distinctive parts. They have a rotational part named hollow shaft, which is tightened by a clamping ring. This is a clamping ring, which is tightened the rotational shaft of is hollow shaft of the encoder on a crankshaft pin. So this shaft is connected to the crankshaft, is part of the engine crankshaft, and it's turning with the engine speed. On this shaft, we are tightening the hollow by a clamping ring, the hollow shaft of the encoder. And we have an outer part which is static and is connected by the frame of the engine using this flexible ring with the purpose to reduce the vibration of the encoder. Encoder are similar in design. A picture from a engine with the encoder B, encoder A. You notice the clamping ring, which is tying inner part, hollow shaft to encoder on the crankshaft. So the encoder are similar in the design. There are different adjustment to the initial position toward the initial position of the crankshaft. So, gentlemen, on the hollow shaft, on the rotational part of the encoder, you will find a semicircular ring. This semicircular ring. So both encoder are similar, a semicircular ring, and the 360 teeth ring. This is they are fitted on the hollow shafts. So they are turning with the engine revolution. On the outer part, on the starting part, you will find on each encoder 4 sensors, 2 marker sensor, named marker master A, marker slave A, and 2 quadrature sensor for the encoder A, and for the encoder B, the name of the sensor are marker master B, marker slave B, and quadrature sensor. Similar, you'll find a semicircular ring and 360 teeth ring. Gentlemen, between the marker sensor, we have a deviation angle 90 degrees. So we have 90 degrees between these two sensors, between the marker and sleeve sensor. What is the difference between the sensors? Sensors are similar, but the difference is that they are taking the reading from different parts of the hollow shaft. So the marker sensor are taking the reading from this semicircular ring. The quadrature sensor are activated by the 360 teeth ring. So gentlemen, per 1 engine revolution, how many times the marker sensor they will be activated? So the marker master A, it's activate when the crankshaft position is 0 degrees and it to remain activate during the engine turning until this end, it will reach this position and this sensor, it will be off. So this sensor, it will be activated on this end, it will reach this area. The engine is turning further and it will be inactive on this end, it will reach this area. So how many times the marker sensor are activated per 1 engine revolution? 1 time, yes? They are activated by this semicircular. So now it's on, it is remain on until this, it will get this position and it will be off. When this ring, it will reach again another revolution, this area, it will be on again. So the marker sensor are activate once per revolution. How many times are activate the quadrature sensor per 1 engine revolution?
Number of teeth.
360 times, yes? So the quadrature sensor, they will be activated according the number of the teeth, 360 teeth. So 1 teeth per each angle degrees. The initial adjustment of the encoder. So the marker master A, the encoder, it's adjust in such a way that the marker master A to be activate when the engine position it's at 0 degrees, piston 1 at TDC. So when the marker slave A, it will be activate. When the crankshaft position, it will be 90 degrees. As I told you, you have 90 degrees between these two marker sensor. So the encoder A, it's adjusted to activate the marker master A at 0 position of the crankshaft. Encoder B, it's adjusted to indicate to activate the marker master B 45 degrees position of the crankshaft. Is it clear? So in this way, they are adjust this encoder. So marker master A, it's activated 0 degrees. Marker master B, it's activated 45 degrees position of the crankshaft. Gentlemen, if so I mentioned that inside of each encoder, we have 4 sensor, 2 marker sensor, 2 quadrature sensor. Encoder A, if you notice the marker slave A sensor is not connected to the Tacho amplifier box. So the wire is going from here. And inside of Tacho amplifier box, you will find the hanging cable is the cable from marker slave A. So this sensor, marker slave A, is not connected to the amplifier box. Instead of signal from the marker slave A, we will receive a signal from the flywheel of the engine. So the encoder are located in the forward of the engine. At the flywheel of the engine, we have an inductive sensor which is giving the same reading which must be given by the marker slave A from encoder. So from inside sensor of the encoder. We are using this sensor like a reference sensor. So this sensor, it's activated at 90 degrees and it will remain active until, so 90 plus 180 degrees, the semicircular ring, 90 plus 180, it will remain active until 270 degrees. So this sensor, it's used as cross check. So when I activate this sensor, it is required to receive 90 degrees measurement of the position of the crankshaft for this sensor, 90 degrees from this one. So it's used as a reference sensor. Gentlemen, let's make an exercise in which we are located all marker sensor on a 300 on a circle. So this is the position of the marker sensor accordingly with the initial adjustment. So the marker master A, it's activated at 0 degrees. We have 90 degrees between the deviation between the marker sensor of each encoder. So marker master A, marker sleeve A. The marker master B, we arrange the encoder B in such a way to indicate the position of the crankshaft at 45 degrees. So marker master B, 45 degrees. I have 90 degrees between the marker master B and marker sleeve B. So marker sleeve B, it's activated at 135 degrees. So during the engine turning, if I stop the engine in this position, we discussed just about the marker sensor. If I am stopping the engine in this position, the marker master A, it's active. All the other three marker sensors are inactive. So the position of the engine, it's somewhere between 0 to 44 degrees. Is it clear? If I turn further the engine, let's assume that the engine is stopped in this position or is in this position, whereas the marker master A, marker master B, marker slave A are active. Marker slave B, it's inactive sensor. So I have these three sensors active. The slave B, it's inactive. So the engine position, it's 90 to 134 degrees. If I stop the engine in, let's assume in this position, and or is in this position, whereas all these three sensors are inactive, just active marker slave B. So marker master A, marker master B, marker slave A false, off signal, marker slave B active. The engine position is somewhere between 270 and 340. So gentlemen, we have roughly position of the engine. We don't have the precise position of the crankshaft. But having roughly position of the engine, we can start the engine on air, because to activate the pilot starting valve and the exhaust valve, it doesn't require to have a precise position. We can start the engine on the roughly position. Starting the engine by air, after 2, 3, 4 revolutions, so the semicircular ring is turning together with 360 teeth ring. After 3, 4 revolutions, when this end it will reach 0 degrees, the quadrature, they will start to count. They are getting alive and they are start to count 0 degrees 25, 0 degree 50, 0 75, 1 degrees, 1 this teeth will be here, 1 degrees 25, 1 degrees 20, 1 degree 50, 1 75, 2 degrees. So the quadrature, they will start to count and they will give the precise position of the engine. Gentlemen, we are using two type of the sensor or two type of the readings. Why? Because if the engine is stopped and we have a total power loss, the fixed position, the precise position of the engine, it will be loose. So I will receive just the roughly position. These three sensors, this will be inactive, this active. By this sensor, quadrature, this is active now. This is active now. This is inactive. This is inactive. By the, if I have roughly position, so now the engine is somewhere between 270 to 315. And if I start now the engine, this sensor, they will count, but they didn't know from where to count, from 271, 300, 310. So I know that the position is roughly. So the sensor, the quadrature sensor, it will start to count when they will receive fixed position 0 degrees. So after the power lose or when we put the engine in service, is required to start the engine. I mean, normal start, but the engine will not give the injection. It will just turn the engine by air. After the quadrature they will get alive, they will start to count the precise position of the engine. Is it clear? Why we are using the two type of the reading? We are using the marker sensor to be able to start the engine at the initial stage, at the putting in service, or in case of the electrical power lose for more than 30 minutes on the engine control system not appropriate, switch off. We are using the marker sensor to have the roughly position of the engine, to be able to start the engine on air. After 3-4 revolution, the quadrature sensor, they will start to count on the teeth ring, 360 teeth ring, and you will have the precise position of the crankshaft. Is it clear?
Yes, more or less.
More or less. Okay, whatever, we'll make an adjustment here, so we'll discuss. Gentlemen, as I told you, the marker slave A is not connected from the signal, is not received by the engine control system from inside sensor marker slave A. Instead of this sensor, we are having an outer sensor located at the engine flywheel, and this sensor is taking the reading from a circular ring fitted in the on the flywheel. As I told you, the connection of each encoder, encoder A and encoder B, is realized to the network by using an amplifier box. So Tacho amplifier box A, Tacho amplifier box B. Each Tacho amplifier box is provided with an LED indication. LED indication, it's activate, it's switching on when the marker master sensor are active. So LED from marker master, from amplifier box A, it's on whenever the marker master A it's activate. So when the marker master A is activate, from 0 to 180 degrees position of the crankshaft. The light on the tau amplifier B, it's on when the marker master B it's activate. So when it's activate, the marker master B at 45 degrees. So from 45 degrees plus 180, it's 225. So from 45 degrees until 225 degrees position of the crankshaft, this LED, it will receive on signal. It will be on. As I told you, the signal from encoder is received to all CCUs and ECUs. Let's access one of the CCUs, and you will notice the electrical connection which is managed by the respective controller. So from channel 40 to channel 47, from channel 40 to channel 47, you will notice the type of the signal is digital input. Marker master A, marker slave A, quadrature master A, quadrature slave A, marker master B, marker slave B, quadrature master B, quadrature slave B. So now the engine is stopped. I will connect the turning wheel to the engine, and I will, let's see the changing frequency of this sensor. So please monitor now the marker master and quadrature, the marker sensor and quadrature sensor, and you'll notice that the quadrature sensor, the frequency of the changing signal, it's more frequent than the marker sensor. Why? Because the marker sensor are changing the values once per engine revolution, as long the quadrature sensor are changing the status 360 times per engine one revolution. Gentlemen, if you notice in our picture, in the picture from presentation, the encoder are enclosed by the metal framing. You can step in that area. They're water dust proof. They have this semicircular, they have this flexible ring which used to avoid the vibration. So they are quite resistant, and the failure of this encoder is not, they didn't give frequent failure this encoder. Mainly the problem of this encoder is the losing adjustment from the initial arrangement position. So as I told you, the hollow shaft, the rotational part of the encoder, it's tied by a clamping ring which is secured by a screw. It's happened that this screw to be loose in such a way the clamping ring, it will allow the slipping of the hollow shaft from the engine crankshaft. In such a way, the position which is sent by the encoder, it's not real position of the crankshaft. So the mainly procedure what is required to be done on board is to check the adjustment of the encoder and to perform a new adjustment. Let's make an exercise. Let's assume that we are operating the engine and you receive the alarm encoder A failure. The encoder A failure could be caused by the connection, poor connection, the failure of the power supply, which is ECU A, poor connection or other kind of the situation. But let's assume that the failure is led by the failure of the encoder itself. So let's assume that is required to replace the encoder A. Okay, I'll disengage this. So let's assume that is required to replace the encoder A. Let's see the maximum turning. Okay. As I told you, we have two encoders, encoder A nearby the engine, encoder B outer the engine. Each encoder is connected to the network by an amplifier box. So you notice the amplifier box A, Tacho amplifier box B. Each Tacho amplifier box is provided with an LED. So LED, it indicates the position of the marker master A. So now it's on. This means that the position of the crankshaft is somewhere between 0 to 180 degrees because this is activated. Also, this one is activated, so the position is somewhere between 45 degrees to 225 degrees. So it's not from 0, how it's indicated this 0 to 180 degrees, because also this one is activated, so it's already passed also after 45 degrees. So it's somewhere between 45 to 225 degrees. So gentlemen, let's assume that we are receiving the alarm encoder A failure and is required to replace the encoder A. To have the access to the encoder A is required to remove the encoder B. Gentlemen, on board the vessel, you will not have display. Display is our crankshaft marking. So this is the local marking which you have on the flywheel on your engine. So we are simulating the local marking of the engine. So if it is required to replace the encoder A, first step is to disconnect to remove the encoder B. How to remove? You are unscrew the securing screw of the clamping ring from encoder B. You notice that we have this screw which is tied in the clamping ring of the hollow shaft encoder B on the engine crankshaft. So you are losing this screw, and now the clamping ring, it will be loose. You are disconnecting the static part, the sensor part, from the flexible ring. So you are disconnect this screw from here, and now also you have the clamping ring loose. You can remove the encoder from the crankshaft. So you pull out the encoder from the crankshaft of the engine. You are disconnecting the flexible ring of the encoder B. So you are disconnecting this flexible ring. And now you have the access to the encoder A. Similar, you are losing the clamping ring of the encoder A. This is B, but I cannot show you on the encoder A. So you are losing the screw. You are disconnecting these bolts of the encoder A, which is tied on the flexible ring on the frame of the engine. And now you can pull out the encoder A. So now you take the spare encoder. So the engine delivery from the maker, you is compulsory to have one encoder in spare, and MPC from it's compulsory to be in spare. So you bring the new encoder from spare, and is required to push on the push back on the crankshaft spindle. Gentlemen, is it required before to introduce the encoder to make an adjustment, to make some setup of the engine?
I guess no.
Is required to put the engine, to turn the engine by the turning wheel at 0 degrees. Okay, so we are turning the engine at 0 degrees because the marker master A must indicate, we are adjusting the marker master A must indicate 0 to 180 degrees, and we can check this on LED indication. So it's required to adjust the encoder at the initial stage to the encoder A to indicate 0 degrees marker master A. So first is required to turn the engine at 0 degrees to have a initial a point from where to start in the encoder adjustment. Because if I turn now if I insert now the encoder on the shaft, you will notice that the marker master A and marker slave A could give on or off signal, but I don't know where is the position of the crankshaft. Could be on or off signal, but I need to have an initial start setup. So I turn the crankshaft at 0 degrees by using the turning wheel. So I connect the turning wheel and I turn the crankshaft at 0 degrees. So I'm using this local indication. If you notice now, the marker master A, it's off. I introduce I put back on the encoder, and the marker master A, it's off. So gentlemen, I need two cameras to explain well, because if now I turn the view on the screen, it's I lose the arrangement from here. So the position of the crankshaft is cross-checked locally, and it's 0 degrees. What is required to happen with the encoder A at 0 degrees? It's required to have the marker master A activate. Is it clear? Because marker master A, it's activated 0 degrees. How we can notice if the marker master A it's on? by checking the LED. So LED is off. My crankshaft is at 0 degrees because I adjust locally by the turning wheel and I cross check locally. So I am aware that the crankshaft is 0 degrees, but the marker master A is off. So marker master A is outside from 0 to 180 degrees. So gentlemen, I keep the crankshaft steady. And as I told you now, the clamping ring is not tight. So I turn the hollow shaft. So I turn the inner part. So I connect the outer part to the flexible ring. And I turn the inner part, the hollow shaft, until the marker master A, it will be on. So now I don't have the clamping ring. So I don't have the clamping ring. It's full. I can turn the in a head direction until the, okay, now it's on. So now the marker master A was activate, but the marker master A it's activate from 0 to 180 degrees. So could be 5 degrees, not 0. I turn a little back to show off. So I turn again the encoder to show off. So now is between 359 and 0 degrees. So I need to stop at the moment when the engine, when the LED is on. So I need to catch the changing from off to on. Now I will know that the marker master A, it indicates 0 degrees. So gentlemen, the crankshaft is 0 steady, check locally. And now I make the adjustment of the encoder in such a way that the marker master A to activate at 0 degrees, position of the crankshaft 0 degrees. Is it clear?
Yes.
I have already set up the crankshaft at 0 degrees, but now I need to make the adjustment of the encoder to show me also 0 degrees. How I can make the adjustment? I need to catch when the marker master A is changing the color from, is changing the status from off to on. Gentlemen, let's assume that now I install now I push the encoder inside and the marker master A, it's already on. So marker master A, it's on from 0 to 180 degrees. So could be 5, 10, 40, 110, 120. But for me, marker master A must show me on the arrangement the real 0, the exact point 0. So when it's turning from off to on. So in this situation, if it's already on, I turn the hollow shaft, so the is the clamping, the clamping ring is still loose. So I turn in the hollow shaft a head direction until the semicircular ring, it will pass on entirely circumference in front of the marker master A. So now I turn. I see that the marker master A, it's off. So now I am aware that the engine position, it's 180 degrees. So is not 180 degrees, just I complete turning a semicircular ring. I continue to turn the hollow shaft in a head direction until I will catch the changing off to on. So that the beginning head of the semicircular ring to activate the marker master A. So, okay, now when I catch the changing of the light from off to on, this means that the marker master A, it's give 0 degrees. And I secure the clamping, I secure the clamping ring on the hollow shaft. Gentlemen, now is required to adjust the encoder B. How will perform the adjustment of the encoder B? When the marker master B is activated?
45.
45 degrees.
Same, but for 45.
Yes, I will change the position of the crankshaft by turning wheel. So now I change the position of the turning wheel at 45 degrees. Gentlemen, you notice the marker master B, it's, sorry, you cannot notice the light, sorry. So the marker master B, it's already on. So I insert the encoder and it's already on. So could be 46, 47, 200 degrees, 210 or 225 because this sensor it's activated from 45 to 225. But for me, the point of interest is to adjust the marker master B to activate at 45 degrees sharp at each. So no, I don't know. So I keep the crankshaft steady 45 degrees and I turn the hollow shaft of the encoder B. I tied the fixed part, the steady part on the flexible ring. And now I turn the inner part, hollow shaft, but I turn in the head ranging engine direction, not a stern. Because if I turn a stern, I reverse the semicircular ring turning. So I turn ahead. So I turn ahead. I keep this during the turning. I am pretty sure to be still on. So I turn ahead direction. I can check the direction of the rotation of the crankshaft. I turn this in the same direction, the inner part. This will be off. So now it's off. The LED it's off. So I turn easily. The position of the crankshaft is remain 45 degrees. Okay, and now it's on. Okay, but probably I turn too fast. I turn a little bit back to make off. So let's turn a little bit back. So it's off, and now I turning easily and in such way to be sure that the hollow shaft turning, what I done my hand, I stop in the same moment when the LED was on. So the position of the crankshaft is 45 degrees. The LED marker master B was on. This means that this sensor is activated at 45 degrees. And now I secure also the clamping ring of this hollow shaft. Is it clear? Gentlemen, is not a difficult procedure. I cut my finger in this plate. It's not a difficult procedure. Whatever is required to have some passion when you make this adjustment. Okay. After you perform any replacement of the mechanical equipment on the electronic engine, we have a procedure to check if the new equipment, in our case, we replace the encoder A, to check if the new equipment it's operating properly, and to check if the adjustment which was done by us was appropriately done. So the procedure must be performed at any time when you make a replacement. For this, we are accessing the MOP. One of the MOP. Let's access on MOP B because we have connected with the TV. So, gentlemen, we are replace the encoder, one of the encoder. Allow me to adjust the camera. So we are adjust the we replace the encoder B. We are accessing the maintenance menu, function test. The function test can be performed on various equipments. In our case, we replace the Tacho system, the encoder. We are accessing the Tacho menu. And the procedure which is required to perform to check if our adjustment was well done is displayed on the MOP. Is required to follow the action request by the MOP. According with the action performed, you will see the reference value of the sensor. Marker master A, marker slave A, marker master B, marker slave A. So this is the reference and this is the actual value of the sensor. So we are turning the crankshaft of the engine by the turning wheel in different position. In such way, we are checking the reading from our marker sensor. If the reading are similar with the reference, this means that our adjustment was appropriately done. Is it clear? So, gentlemen, we have two level access of the MOP. One level access, it's operator. So system option, it's operator, where we can just monitor the engine parameter. To make any adjustment of any test is required to change the access of the MOP from operator to chief level. We are pressing this button and we are inserting the password. The password is BADO8, Bravo, Alpha, India, Oscar. Wait a little bit. Bravo, Alpha, Delta, Oscar, India, Tango, chief level. And now you will notice that the system option, it's accessed under the chief level. So the password is BADO8, Bravo, Alpha, Delta, Oscar, India, Tango. So let's perform the procedure function test for Tacho. First step, it's preparation start. I press start. The step one, an assistant is standing by at the turning wheel. So I send one of the crew members, second engineer, third engineer, with to connect the turning wheel and to be present in the area of the turning wheel. When the crew member reach that area, I confirm this step by pressing done button. Let's start the test. Test of Tacho signal start. Step number one, turn engine 2 degrees before TDC. So 2 degrees position of the crankshaft before TDC. All the marker sensor, master and sleeve, are inactive. So you notice the reference value, all of them are false signal. Our actual values is indicate marker master A true, marker slave A false, marker master B true, marker slave A false. So we'll notice that now the engine is not 2 degrees, but we didn't ask yet the crew member to connect the turning wheel and to turn 2 degrees. So now I ask, please, third engineer, connect the turning wheel and turn the engine 2 degrees before TDC and cross-check this locally because we have local indication of the crankshaft position on the flywheel. So he's connecting the turning wheel and using the turning wheel is turning 2 degrees before TDC. And now he's called me in radio, Chief, the position of the crankshaft is 2 degrees before TDC. Let's see what is happened on our test value. So the signal from encoders, it's similar like reference value of the sensor. So for the first step, we are was complete. Gentlemen, if we turn 2 degrees local and one of the sensor it's active, this means that our adjustment was poor done. So it's required to perform adjustment for the beginning, from the beginning. Put the engine at 0 degrees, lose the clamping ring, untie the screw, lose the clamping ring, turn the hollow shaft in such way to marker master A to indicate 0 degrees. So you are turning from off until you get on indication. And when it's done this, you are securing this ring. So gentlemen, why is required to turn this in a head direction? When you are turning the engine, you need to turn ahead. This end must activate this marker master A. If I turn this end, I turn the engine a stir, this end, it will activate the marker master A. And you'll suppose that now you have 0 degrees. But when you turn the engine ahead, this end was activate the marker master A, and this end, now I turn the engine normal, this end, it will go in this area. So it inactivate this. So if I turn this end, sorry. So if I turn the hollow shaft now, the engine position it's a 0 degrees, and I turn the hollow shaft a stir, I will activate the marker master A with this end, which is wrong. I need to activate the marker master A with this end. So when I make the adjustment of the engine, I adjust the engine crankshaft at 0 degrees locally, and is required to activate the marker master A with this end. 0 degrees because it's required to be active from 0 to 180 degrees. So 180 degrees must be activate this sensor. Is it clear? So let's turn to the function test procedure. So I turn the engine 2 degrees before TDC. I notice that the test value are actual with the reference value. And I can complete this step by pressing the button done. Step 2, reboot CCUs and ECUs. Is required to reinitialize the parameter for CCU and ECU. To done this step, we are pressing the button reboot. So I press the button reboot from here, reboot, and you notice a circle which is indicate the timing of rebooting. It's around 4 minutes. Sometimes this circle, it will indicate earlier initialization. So allow around 4 or 5 minutes. If this is showing earlier, don't start to perform the step number 3 immediately. Just allow a time. You'll notice it's showing already that the initialization was done, but is required to check locally the MPC that the LED to be in a red condition. On my simulator, it's still in yellow, it's still booting. Similar, it will happen on the engine. Just allow a little bit longer time this rebooting to take place. But you can cross-check local on the LED indication that the LED to turn in green. They are still orange. You notice now the readings was disappear from there. This means it's still rebooting. Okay, let's wait a little bit longer. I see that we have some reading also appear there, but okay. Step 3. So after booting, automatically the procedures jump to the step 3 turn engine in a head direction 2 degrees after TDC. If you notice 2 degrees after TDC, the marker master A is activate on our engine. You notice that the marker master A feedback signal is still false. But I didn't ask yet to the crew member to turn by using the turning wheel 2 degrees after TDC. So gentlemen, I asked the crew member to turn 2 degrees after TDC. And let's see what is happened. So we notice that also the value from the marker master A, it's true. This means that the encoder A was well adjusted, and we confirm this step by pressing done button. Step 4, turn the engine 47 degrees. Similar, I asked the crew member to turn 47 degrees. The crew member was turned 47 degrees, but we noticed that on remote, so the crew member is confirmed, Chief, now the engine local is 47 degrees. But on my MOP, I noticed that the marker master B, it's still off, but this sensor at 47, it's activating the 45 degrees. This means that I make a poor adjustment of the encoder B. So it will require to adjust the encoder B again, put the crankshaft position 45 degrees, lose the clamping ring of the encoder B, adjust the encoder B in such a way that the marker master B, LED of the amplifier B to switch on exactly on the position of the crankshaft is 45. So we are adjusting, turning ahead, hollow shaft turning until LED is getting on. So, but on my engine, I didn't ask yet. So I ask now, please turn 47 degrees. So the crew member is turning 47 degrees, and let's see what is happening. Okay, we notice after turning 47, also the marker master B is active, and we can confirm by pressing done button. Turn the engine in a head direction 92 and 90 degrees. The marker slave A is activate, so I ask the crew member to turn 92 degrees. So now the indication, the sensor, it's the sensor from the flywheel. So marker slave A, it's activated, so flywheel sensor, it's activate and is true reference, true, it's the test value. Turn the engine in a head direction 137 degrees. So I will turn the engine 137 degrees. At 135, the marker slave.
You forgot to press done.
Oh, shit. Gentlemen, if you notice now, if I turn this, okay, let's press done, because after that is required to abort the test. So I'll go back to 92, yes? 92. Let's wait. Otherwise, if I forgot, okay, if I forgot and is required to abort the test to start the test again. So now I can press done button. Turn the engine in a head direction 137 degrees. So I'll turn 137 degrees. Okay, and you notice that also marker slave A, which is 135, was activated. So I press done. So gentlemen, in this moment, we can conclude that the manual adjustment of the engine was well done. Is it clear? Whatever is required to perform another test, which the name is setting of fine adjust parameter. We are taking 15 minutes break and we perform a fine adjustment of the encoder. Okay?
Yep, okay, great.
Okay, if you have question, please address. If not, let's take 15 minutes break and we discuss.
So,